Yes, very good afternoon to one and all. What we have seen yesterday, we have seen robot applications. Whether it is audible, my slides are visible, and my audio is clear.
Yes, sir.
Yes, sir.
Yes, this is what we have seen yesterday. And a small recap over the yesterday's presentation, that is a robot application. It is classified into industrial and non-industrial applications. And industrial applications, we have seen material handling, process application, assembly, and inspection. And in view of non-industrial applications, research and exploration, and in particular we have in detail we have seen the material handling equipments and various classifications of material handling equipments used in industries with the aid of robots and its applications. This is what we have seen yesterday, and today we will target the robot programming, that is which were in our syllabus. It is in third unit, and today we will target we'll start we'll slowly will introduce the uh, programming, and please make and this is what we are going to see today, that is a method of programming, link to programming, manual programming, robot program in space, method of defining point in space, and speed control. And what is the need to have an revisit over the program languages, and this is what the control of motion of robots having different structures and geometric capabilities. And some of robot languages have been developed by modifying the existing the computer languages, and on the other hand we some effects of various researchers at Stanford Artificial Intelligence Laboratory, research laboratory of IBM Corporation, under US Air Force sponsorship, and General Electric Company, Unimation, and many other robot manufacturers are using their own programming languages. But now we are going to concern about the whale. I have already introduced the abbreviation of the whale, that is variable assembly language. That is what the Unimation did, and even some other robot programming languages also available, that is AML, AML mean a manufacturing language, and Wave is introduced between 1970 and 1975, and Artificial Intelligence Laboratory of Stanford University working towards developing programming languages, and machine control language. Douglas introduced the machine control language, and this is what the origin about the programming language, robot programmings. And see, this is what slowly we will target, will hit over the programming languages. See, this is what the robotic and we need to be familiar with the
Excuse me, sir.
Cartesian coordinates.
Excuse me,
Yes,
sir.
yes,
Sir,
yes.
your voice is going off in between, sir.
Oh, wait, wait.
Yes, sir.
Yes, now check with audio. I think there won't be any interruptions with the audio, right?
All
Am I
now it's
right?
fine, sir. Excuse me. All now it's fine.
Yes, sir. Now
Yes.
fine.
What from where we need to start? We, we need to start from the Cartesian coordinates, and we need to make many grids not to make a single move. We need to depend the grids over the Cartesian coordinates. See the simple Cartesian coordinate given to you, and see the one would be the left lower left corner, and the movement has to be occur based on these points which is highlighted here, 2 1 2 2 and 1 2. We have two different axes, axis 1 and axis 2, and see, assume there are as well as this is the end, as well as this is what the end point. What we need to do, we need to take a path, take a travel from 1 1 to 2 1 and 2 2 and 1 2, and even this may also possible from making you move from 1 1 to 2 2, and as well as 2 1 to 1 2 are also feasible. And this is what we need to be aware while building the robot programming, and this is what we need to refresh with these Cartesian coordinates. And see some other here we have given 5 different steps, and 2 1 2 2 1 2 and 1 1. Move to lower left corner, move to lower right corner, and upper right corner, upper left, and then again back to the origin. And here we don't have 2 2. See, here we don't have the 2 2, and this is what the path we are going to miss when compared with the last example. So what happens, the robot movement will occur from 1 1 and then 2 1. It straight away it moves to 1 2, and then again it return backs to 1 1. And what we have to aware, the path of limited sequence robot with jointed move in sequence, and this is the path which we were doesn't take when compared with the. And see, this is the example for 8x8 grid, and when we are trying to have a movement from 1 1, see this is the point of 1 1. This is the point of 1 1. From 1 1 we are going to make a move to 8 8, and what we need to do, from 1 1 to we need to take a move to 8 1, and then 8 8, and then again 1 8, and then what we need to make a move with these workspace. And see, from 1 1 to 7 4, when we are having the move from 1 1 to 7 4, what happens, and it moves to 2 2, and then 3 2, and then 4 3, and then 5 3, and then 6 4, and then 7 4. This is what they move from 1 1 to 7 4. The as we are aware about the starting and ending point, what it takes, the internally generated interpolation points, or these are the interpolation points which usually the computer may take, and this is what the shortest route taken by the computer itself. And see, I'll little more will make a brief about these points. And the linear joint 1 must move 6 increment, and joint 2 must move 3 increments. And to determine the joint interpolated path, the controller would determine a set of intermediate addressable points along the path between the 1 1 and 7 4, which was given here. And this is what the interpolation. There are 4 interpolations are usually preferable in the case of robot programming. One is joint interpolation, and the second one is straight line interpolation. The third one is circular interpolation, programming, or either
Sorry,
it can be
after
called
the
as an irregular
straight
smooth bridge.
interpolation, everything got cut, sir.
No, I didn't get you. Little
Sir,
louder.
you told some straight line interpolation. After that, your voice was breaking, sir. Nothing was clear, sir.
Oh. Wait, joint interpolation. The first one is joint interpolation, and the second one is straight line interpolation. The third one is circular interpolation, and the last one is irregular smooth motion. This is what robot programming. You make a note of these commands and all. Wait, signal, and delay. There are a few commands we need to remember for doing robot programming. We'll start from these three: wait, signal, and delay. And I'll once we are familiar with these basic nomenclatures, again we will revisit over this example, and how these motions, how these intermediate points were considered by the robot. Will discuss in detail once these nomenclatures were introduced. And is wait, and all industrial robots are instructed to send signals or wait for signals. Either it has to give some commands or it has to wait for some time, and these signals are called interlocks. And common form is to actuate the end effector. What we are for what purpose we are doing so is in order to give a motion for the end effectors. We are doing so. And in grippers, it's on, either on or off or binary. This has to be in grippers. And concerning grippers, it has to be in three different states, either in on or off or binary. Grippers involve two interlocks, either open and close, and feedback might be added to verify the actuation. And the communication with other devices is very important. And see, you please make a note of this signal M, which means, which I have given here, and signal M, which instruct the robot controller to output a signal through line M. The robot controller to output a signal through line M, signal M. And what might be line M? We were given the number line, various line numbers, where M is one of the several output lines available to the controller. M would be the lines, several output lines. In order to call one particular line, we are using M. And what is signal M? The robot control to output a signal, we are referring this one. And wait N, which indicates that the robot should wait at its current location until it receives a signal on line N. Line N again, where N is one of the several input lines available to the robot controller. And this is what we need to start: signal M and wait N. And as I said earlier, there are four different interpolation. This is what the example for one among the interpolation, that is circular interpolation. And there are four different points were highlighted here. One, you see here the second point, the third and the fourth point. We'll discuss more about it later. And signal M and wait N. And for doing loading and unloading, what we are going to with an example, will see these various informations related to loading and unloading. And I hope that you are writing for. I'll request some 10 people to join with us till the end. You please unmute your mic and please join this. 31 to 40. Sorry, today 41 to 50. That is 43, 44, 45, 46, 47, 48, 49, 50, and 50 to 53. And you please unmute your mic and please join this.
Yes, sir.
Yes,
Yes, sir.
I think KD Singh is also available.
Sir, KD Singh is on leave today, sir.
Oh. Okay, fine. I think hope you are writing. Is it so?
Sir?
Hope you are making the notes, right?
Yes.
Else you else you are Please make a note of each of every programming content. Yes. See, this is what we need to do. What in what way we can do this tot bin, and this is what we need to address. You please make note of this diagram. This is an layout of the work cell uh, and the pattern of the press, where
Gloves of outer coat, normal hand.
the robot must drop the parts in the tot pan. Here we have the tot pan. The robot has to either that might be the dustbin.
Without
Use this side. Here we have a dustbin. The robot must drop the parts in the tot pan located at 1/8, and one of the column of the press is in the way of an easy straight line move from 8/8 to 8/8 to 1/8. Robot, then what happened? The robot must move its arm around the near side of the column now to avoid colliding with it. There are what we need to do. I think have you written? Have you drawn this thing? Assume there are many grids in between 1 1 and 8 1. There we have various grid points, and point 8 1 will be our position to wait for the press to open before entering, the press to remove the part, and the robot will be started from point 1 1, a point in the space which is known as the safe in the known to be safe in the application. And see here, start at home position 8 1, move to wait position 8 1, and wait 1 1, wait for press to open, and 8 8, move to pick up point. Here we have some points, some debris is available at 8 8. Signal 5. What it happens? What was signaled? Signal, that is controller to output a signal through line M. Signal gripper to close. It has to pick up the debris from 8 8. And then 8 1, move to safe position 8 1, again it return back to 8 1, and signal 4. Signal press to actuate, and 1 1, move around the press column and move to the dot pan. 1 8, move to pan, and 1 1, move to safe position, and 8 AC 8 8, press 1 8, we have tot band or collecting tray, and 1 1 8 8 will be the safe location for waiting. 1 1 and 8 8 would be the safe locations. And control part 1 to 10, output line signal, 4 actuate press, 5 and 6 open and close grippers, Okay. See here, some commands we need to remember, and in order to understand these principles, we need to know about the basic commands. And please make a note of these commands. That is wait 1 1, wait for start signals on line 1 1. These are the some commands we need to we are going to read in the subsequent classes or in the uh, later session. And you please make a note of these three commands, that is wait 1 1, signal 5, and signal 6. Wait 1 1 would be wait for start signals online 1 1, and wait signal 5 would be open gripper, and signal 6 would be close gripper. Move safe, move to starting safe positions, and move inter. Go to the intermediate point above chat. Wait 1 2, wait for next part from chat, and signal 5 move pick up, gripper to pick up part, and signal 6 close gripper, move inter, and move above 1, move lock 1, signal 5, and above move above 1. And all there are 14 different lines, or sorry, 12 different lines are given. And again we will revisit these 12, and what you have to write, you write these three: wait 1 1, signal 5, and signal 6. Wait 1 1 is used to give the wait for start signals. It has to wait for getting the signals, and signal 5 would be the open gripper, and signal 6 would be the close gripper. Eight. Yes. Yes, you please make a write, make a note. I think you've drawn this diagram, and write these contents. I will explain. Signal 4, what would be signal 4? I think you don't know. Again, you please make a note of this content. I tell you, what was the difference between these two? What we did here, we were given the delay. See here, we doesn't have any delay over the signals, and here we have added delay. Delay 1 SEC, which indicates the robot should wait 1 second before proceeding to the next step. And if it is in 10 second, delay will be in 10 seconds. Delay has to be occur uh, after 10 seconds, and therefore what we need to use for now to give a delay x ACC x, which means x is in amount of seconds which we are requiring to perform the delay. Now see, and what we are what we have what is the difference between the signals and with some delays and without some delay. And this is what we have. We have the drop off here, and we need to pick up here from debris 88, and we need to drop off at 0.18, and with some delay we are doing in two different ways. And 1 might be the starting point, and 8 1 it has to move 8 1, and then wait for press to open, and in order to open the end effectors we are giving wait 1 1, and 8 8 move to pick up point, and it has to move to 8 8, and then gripper close. Now the gripper has to pick the point, and 8 8 again 8 8 would be the safer point, and signal 4 signal press to actuate, and 1 1 move around press column, and then move to third pan. What happens? The movement has to be taken here 1 1 8 1 8 8, and it takes the same path 8 1 1 1 and then 1 8. Move to that pan again, signal 6 signal gripper to open. Now to drop of the debris we are using signal here, signal 6 here, and then move to the safe positions. And then here what we added here, it has to pick up from 8 1 8 8, and then it has to get some delay at 0.88. Similarly, the delay has to be occur at 1 8 once the material is dropped. And even some material has to be dropped even till once again, like a rice bag or cement bag, or it might be a sugar bag. The dropping may occur even for a second, even for a minute. That has to be given here. Now by the way of giving delay x seconds, we can give delay over the robotic program. And branching, and see some basic commands. You please make a note of these commands. Safe locations to start and stop, pickup location of part, pickup at end of chat, intermediate point above chat to pass through, and LOC1 location of first pallet position, LOC2 location of the second pallet position. Similarly, we have 24 pallet positions, and see here there are 24 different pallet positions are available. With this we are going to have some program numbers. LOC1 to LOC24 we have 24 pallet positions. Above 1 location above pallet 1 and till 24 we have different pallet positions. See here, pallet with 24 position used to illustrate branching robot program. Move safe, which means that the robot should move its end effector to the point in space called safe. That point has been defined, so the robot knows where to go when it comes to that instruction in the program. And please write 1 move safe, move to the starting safe position, and wait 1 1, wait for start signals online 1 1. The following portion of the program directs the robot to pick up the first part. See, we have to be very conscious. It has to pick up the first part. These are the commands used to pick up the first part. Similarly, Now to pick up the second part, we need to adjoint 1 prior to the this numbers. Here what we need to do, we need to convert into 2 0, 2 1 and 2 2. See 3 4 5 6 7 8 9 10 11 12, the same number, that is 13 14 15 till 19, then 20 21 22, and which is used to pick up the second part. Similarly third part, fourth part, till 24 parts, what we need to do, we need to add a number prior to the or we can use 0 0 0 4 0 and 0 5. We need to add a number with 0. If it is in first part, we need to add first with that 0, therefore that becomes 1. Already here we have 1, therefore it becomes 2 2 2. And if it is in 24th part, here 24th part, what happens, we need to add 24 here, 24, this is the 23rd part, it would be the 23rd part, and the next portion of the program directs pick up 20, it might be 24, and this serial has to be 24, this would be the 25 right. See here the second part, sorry, the second part might be 2, we have 2 right, then it would be the 24 mean 24 0 24 0 1, and see here 2 3 2 for move interlock. Similarly we can move 24 different parts by using these different program lines. And move safe, wait 1 1, move enter, wait 1 2, signal 5, move pickup, signal 6, move enter, move above 1, move lock 1, signal 5, move above 1. And the palette is now full. Then move enter, go to the intermediate safe positions, and signal 7, signal that palette is full. If the signal 7, then it means the palette is full. This portion of the program is repeated below, indicating where the subdivisions occurs the following the fudge subtask 1 3 1 4 1 5 1 6 1 7 and 1 8, and move enter, go to the intermediate point above chat, and move 1 2, signal 5, move pickup, signal 6, move enter. You please make note of these languages, and we have to be detailed in a detailed way. We will discuss in the subsequent class. 19 move above 2, 20 move log 2, 21 signal 5, and 22 move above 2, and branch fletch, move enter, wait 1 2, and you please make a note. Signal 5 move pickup, signal 6 move enter, end branch, and which is used to end the branch, and branch place indicate the following is branch place. Move Z minus 50 position part in palette, signal 5 open gripper to release part, move Z plus 50 D part from pickup point, end branch, this is the end of the branch, move above 2, move to point above second palette location and place. Call branch place for execution. With that, you add a few more. I'll tell you. 85 step 85 fletch 24th part, and 86 move above 24, move to 24th position, and 87 place 24th part, and 88 move enter, go to intermediate safe position, and 89 signal 7 signal that pallet is full. And you please write these 5 different steps, that is 85, 86, 87, 88 and 89. With some examples, I'll make a detailed note about these contents in the subsequent week. Okay, I think there won't be any doubts with today's class because we were nothing delivered today. We were introduced to various codings. And concerning the submission of the assignments, yes, do you have any request or any appeal?
Yes, sir. Can you extend to tomorrow, sir?
Tomorrow, what would be the preferable time? Till what time you can submit?
Sir, till night, sir.
Till 9.
11. Yes, sir. Till night, sir. 11:59.
11:59.
Uh,
Others, are you ready? Tomorrow, it is enough. That time is enough to submit the assignment.
yes, sir.
Yes, sir. Wait, I'll check. Rakshika. Rakshika,
Yes, sir.
Yash. Yes, this way. Tomorrow itself we can submit.
Yes, sir. Tomorrow.
Yash Mohan, Dhruv Gupta, Rohita.
Yes, sir. Tomorrow, fine, sir.
Okay. Then I'll extend in classroom. I'll extend. Okay. Do you want anything to share with today's content? I think we were introduced to various basic informations, and I didn't explain a lot. Tomorrow, in the next class, I'll explain. At that time, you might have some doubts.
Yes, sir.
Any other information?
Sir, regarding CT2, can we have an idea about when it will be, sir?
We'll plan. What was the slot given by the class committee chair?
No idea, sir.
Okay. Anyway, today or tomorrow, I'll upload the course plan, and with that you can find that we, as per our convent, will have the CT2.
Okay, sir.
So CT2 will be in April first week now for the robotics.
Abhishek?
So it
Pardon?
will be held on April first week now.
April 1st week.
Hmm.
That is the
So
preferable week.
because as the other profs are planning, so according to that, I am asking you, sir.
Okay. We'll have a discussion and we'll decide.
Okay, sir. Okay, sir.
Okay. We'll meet during Monday, and with that, during March 30 also, KD Singh requested to have. What was your plan during March 30?
Sir, we are
March 30.
planning to have holy holidays, sir, and we also have Pragyan during that time.
Balaji, I think there is an issue with your audio. Abhishek, you go ahead, Abhishek.
So like he is telling, sir, that we are planning to have the CTs after the holy holidays, and we are having Pragyan also in between. So we are planning in April for all the CTs.
Okay. Anyway, once KD Singh come, we'll discuss. Okay, we'll meet during Monday. If feasible, you revisit these video lectures and please make note of all the commands which we are introduced today.
Okay, sir.
Okay, we'll meet during Monday. Thank you.
Thank you.